Okay, today's video is going to be a little bit different. In simple terms, what I'm going to be doing is I'm going to be explaining how to create graphing calculator programs for especially the ACT that works for the TI-84 Evo. If you are someone who is taking the ACT and maybe a little bit more technically inclined, this might be for you. I am not a coder, but that being said, I've learned a few things that you can use Claude to create about any program that you want. On the side note, after this, if you feel like you just want to download some programs right away, you can go ahead and check the description, and there will be a link to purchase actual calculator programs. But I figured I have a few people that I know that would be really curious, like how to actually do this. And this is taking a couple renditions. Okay, so specifically, this is for the TI-84 Evo. And the key with this is I have to build it in a different programming language, which is Python. These would not do super well on the TI-84 Plus CE, even though it has Python. But if you want some videos of how to create those programs with Claude, let me know in the comments. But that being said, I have created this prompt. I will link it. It's completely free. Just you copy and paste it from the Google Doc, and we'll go from there. So kind of the first step is, like I said, you got to copy and paste it. If you just ask this in Claude, it would not work too well. So what we need to do is we need to copy and paste this text. And then we also need to upload, ideally, an ACT problem that hopefully be solvable by using a calculator program. Now, the ones that are typically solvable by calculator programs are ones that can use simple solving functions. I'm really passionate about making sure that we follow the rules for this. And whenever it's finding some simple numbers, pretty much you can use a calculator program unless you're solving like really complex triangles and circles. And yeah, so I just think certain things like this make it easy. This is a question where we are finding period and amplitude. We give it the prompt template and we want it to make a program. So I don't really have to think on test day or like remember all these formulas. So once we upload all that, upload the photo, we pretty much let Claude do the work. Okay, so that took a couple minutes, but that's not unusual. And yeah, so it's pretty much done. What I like with this prompt, and I kept it in there, is it gives a source code. And what's really cool is it kind of gives some instructions on how to use it. Does everyone look at this now? but it can be helpful. The key thing that you need to know how to do at this point is you go ahead and click download. And this one decided to name it Sign, PER, and you can talk to it if you want to name it something completely different. And then what you need to go to next is, and you can always Google it, but it's like the TI Evo website. And then what you need to do is you need to go ahead and go to connectivity and then launch the TI Evo Connect. So let's go ahead and connect our calculator. Connect. And then it's going to ask you to approve it. At least on my computer it does. So what we are looking at here is a very few amount of options, which is good. So we're going to ignore these and we're going to click send files because we are sending files from the computer to our calculator. So what you can do at this point is you click the little downloads and it might look differently, of course, on your computer. And for me, I just drag it because I see it popping up there. And it looks like it's loaded, which is good. And then I'm just going to go send. And the way that we check it is pretty straightforward. So how you're going to test it is actually pretty straightforward. So if we reference back to question number 19, what we're going to do is we're going to hit program. And then on program, you're going to go to Python. Right now, the TI Basic is not working super well. And you hit enter. And then once you find your program, which this is ours right here, you hit enter. What you really need to pay attention to on this is that there is actually a lot of instructions built in. You have to make sure you follow the instructions. And it's telling you how to type in that 6 times pi. So on this example A, it's telling us the example and what pretty much A is based on the y equals above. So what you can do is you type in 2. You hit enter, and then it's going asking for B inside the coefficient, and it gives us an example. So I go 6, and then I go times, and then I go second pi. And that's going to get our correct answer there. And you can use this interchangeably, but it's also just a really helpful reminder of how to structure it and how to solve, which is fantastic. So in summary, we covered how to create a graphing calculator program with Claude that you can use on the ACT. I am going to go ahead and link our programs below if you are interested. I'm also going to link the Google Doc as well. The Google Doc with the prompt is free. And a couple of notes is that Claude is not perfect. The prompt is not perfect. And the best thing you can do is if you are running into errors, and I've run into plenty of errors while creating these programs, is you tell Claude or the AI system that you're using exactly the errors, and most of the time it'll fix it. And then you re-upload and go from that again. So that being said, if you like these type of videos, let me know. I'm going to be cranking out more calculator videos just so that more people know how to better use it on these tests and in general for the math class. But regardless, I hope you do well on your test, or at least this helps you out a little bit, but I hope to see you soon.